Hi guys, in this video we are going to take a look at normal distribution, and we are talking about wingspans of adult herons. These are very beautiful birds. In fact, we have them at our lake. I'm fascinated by them. So let's just say that the mean wingspan is 123 centimeters. The standard deviation is 10.6. We would like to know what proportion of herons have wingspans less than 97 centimeters. So let's open up the normal calculator. And we need to change the mean and standard deviation because by default, this is standard normal with mean 0 and standard deviation 1. But here it's 123 and 10.6. So once we change it, we also want to go ahead and zoom fit so that we can see the graph. All right, so if we want less than 97, that means that 97 is going to be the upper bound. So that's going to go 97 over here. And it's also going to shade the curve, right? So you can see how the area to the left of 90, to the left of 97 is highlighted. And so this is my answer. Now, if you want to round it to 4 decimal places, you can just put round and then highlight the number over here. Paste that here and say 4. Okay, so that's going to be my answer, 0.0071. So very, very small number of herons have wingspan of less than 97 centimeters. Now, here the next one says proportion of herons with wingspans between 109 and 139. So, okay, so let's put 109 for the minimum and then 139 for the maximum, so we can see that the shaded area here on the picture. If we want to go ahead and round, let me see if I can get rid of what I have here. Just highlight this answer, 4 decimal places. Okay, so that goes in here. The next question says, determine the proportion of herons that have wingspans greater than 154. So if it's greater than 154, it should be 154 for the lower bound, and then there shouldn't be anything for the upper bound. Okay, so I don't really see much over here. I might have to zoom closer, but to me, this looks like almost 0. If you keep zooming in, you will see it. So I think this answer is very, very small. So if I were to enter it, that's going to be 0.0017 because the next number is a 2, so I don't have to change it. Okay, so that's a very, very small answer. Okay, let me go back and zoom fit it. Now, the next question talks about some sort of percent. So in any time you have a question that asks you about percent, you are working with inverse CDF function. Because the way this function works, so CDF stands for cumulative distribution function. It says, give me the area to the left of a number, and I will give you the number. So it's like an inverse. It's telling you what number do we need to look up so that the area to the left of it is a certain value. So we are using inverse CDF for any percentage question, so like D, E, and F. All right, so before I move on and do anything else, I want to uncheck this box so that there's just less stuff on my screen. Because I do not need the cumulative distribution function at this point. I just want to manipulate this inverse. So first, if it says smallest 20%, that is the same thing as saying 20th percentile. So one thing you do need to understand is that you can't just type 20 over here because, well, obviously it'll say it's undefined, but you need to convert the percentage to a decimal first. So you would divide by 100, that's 0.2, and that's what you would put in the inverse. So the herons with the smallest 20% wingspans would be 114, and I guess 0.1. Let me see if I can round this answer. So let's just highlight this and say round to 1 decimal place. Okay, now this one says the largest 10%. Again, there is a percentage, but remember that the inverse CDF function wants the area to the left. It's not going to give you the answer if the area to the right is given. And here you have the largest 10%. So what you need to do first is figure out if I am the largest 10%, what is the bottom percent? Well, because the total is 100, the largest 10% is the same as the bottom 90%. So how do I know that? I'm just going to subtract 10 from 100 and I get 90. So at this point, I will also go ahead, divide it by 100 and pass that to the inverse function. So that'll give me 136.6. finally, I am trying to figure out the middle 70%. So this is probably the trickiest question. So first of all, the middle percent should always be between, so that the mean is in the middle. Here I have the standard normal, but I mean the idea is the same. So there'll be some number over here and another number also symmetric on the other side, so that the area between them, so this whole area, if I were to shade it, all of this area right here, that's equal to 70%. So this area is 70%. Now remember that the inverse wants you to pass the area to the left. So it wants this part. How do I get that? Well, because the total is 100, I will need to subtract 100 minus 70 first. That'll give me 30. But 30 is the leftover. It's both tails, not just one of the purple tail here, but let me shade this other one. That's the blue one. So the total of purple and blue together is 30%. But I only want one tail, because inverse says, okay, give me the area to the left of me. And to the left here is the area would be not 30, because you got to divide it by 2, right? So you're going to divide it by 2, and then that's going to be 15%. So if this is 15%, and then also this is 15%, then the total will be 100, right? 15, 70, 15. So to find the first cutoff, we want to look up 15% in our calculator. But again, 15% will not be 15, it's going to be 0.15. So that's going to be my left bound. So that's 112.0, I guess. Now I have to figure out the right bound. Again, what did I do? I took 100, I subtracted 70, whatever I got, I divided that by 2, and then I divided it by 100 to convert to percent. So now it's going to be 0.15. Finally, I want the other number. So the other number that I don't know is going to be over here. So I'm asking, what will be the area to the right? No, sorry, to the left of this number. To the right, actually, it will be 15%. So to the right would be 85. But do you see why it's 85? Because it's the green and the purple total. And so that's going to be 85. So that's what I will need to pass to the inverse. So 0.85. And that'll be this number right here. Well, actually, it's going to be a little bit tricky to round. I think it's going to be 114.0. But let me check that just to make sure, because there's 98 and I'm rounding to one decimal place. So, whoops, not 114, 134. Sorry about that.